Hey, we have here today another integral from the MIT Integration Bee 2023 regular season problem 6. We have the integral of x to the 6th plus x to the 4th minus x squared minus 1 over x to the 4th e to the x plus 1 over x dx. Okay, now the first thing that's going to jump out to me is just this exponent on e. I'd like to simplify this. What we'd really like here is just e to the x. We'd like to simplify this expression. And so what I want to do to handle this is just a u substitution. I'm just going to make my u that exponent, which is x plus 1 over x. And we'll take our derivative of this. So we're going to have du, derivative of x is 1. Derivative of this is going to be just minus 1 over x squared dx. And then before I substitute, I'm going to want to deal with this and try to simplify this and maybe try to make use of some of these values we have over here. And of course we could just divide in our x to the 4th and that would be fine. But what I want to do instead is kind of break this out separately and see if we can factor it out a little bit. And so to start with, what I'm going to do is looking at just x to the 6th plus x to the 4th, I'm going to factor an x to the 4th out of that right there. So we'll factor an x to the 4th and we have x squared plus 1. And then I'll factor a minus out here so that instead of having minus x squared minus 1, I'm going to write this as x squared plus 1. And I'm just doing that because then we'll have this term in common. So then factoring the x squared plus 1 out of this, we're going to have x to the 4th minus 1. But then this is a difference of two squares. So we'll just bring this first term over, but then with difference of two squares, we can write this as x squared plus 1 times x squared minus 1. And now we have two of these here. So what I'm going to do is write this just as x squared plus 1 squared, and we'll have x squared minus 1. And this is going to be over x to the 4th. What I'm going to do is break that up. I'm going to write take my x to the 4th, and I'll write an x squared over here to divide into this one, and we'll bring an x squared over here for this one. Dividing x squared into x squared minus 1, that's going to just give me 1 minus 1 over x squared. And I like that just because it's exactly what we have at the beginning of our du right here. And then for this first part, what I'm going to do is take this x squared plus 1 over x, and we notice we have a square power on both, so I can write this as all squared. But then just one more step, I'll divide my x into x squared plus 1. So dividing an x in, that's going to give me x plus 1 over x, that whole thing squared, times 1 minus x squared. And we notice that this is the same as our u value up here. And so here we have our u, and here we have part of our du. And so what I'm going to do is take this back and put it back in our integral, and let's continue. Okay, so now we've done all our algebra and put it back into the integral. And again, we have our u here and here, and we have our du right here. So everything is set up for me to just make a quick substitution. So doing that, we're going to have up front, we'll have a u squared. Here, this is just going to be e to the u, and this is going to be du. And this integral is actually not too bad. This is something we can do with integration by parts. I'm going to set up the DI method or tabular integration. I'm going to differentiate u squared and we'll integrate e to the u. Then we'll just differentiate down this left column. So differentiating u squared, we're going to get 2u. Differentiating again, 2. One more time, 0. Then integrating eu is just going to be eu, eu, eu all day long. And then we'll have our solution in u right here on the diagonals. The last row is 0, so we don't have to worry about that. That's going to be gone. So what I'm going to do for this is, since we have an e to the u in each term here, I'm going to factor out an e to the u, and then just look what we have on the left here, which is just going to be u squared minus 2u, and then a plus 2. And then I'm just going to back substitute to finish this off. So first here, we're going to have e to the x plus 1 over x, which is just like how it was in the original. Then for u squared, this is going to be x squared plus 1 over x squared plus 2. Then a minus 2u is going to be minus 2x minus 2 over x. And then we'll just have this plus 2 here. And then I can just combine this 2 with this 2. So for our final solution, we're going to have e to the x plus 1 over x, x squared plus 1 over x squared minus 2x minus 2 over x plus 4, put a plus c, and we're done. So that's it. Not a hard integral, but we did have some algebra to manipulate. So we'll stop it there. Thanks everyone for watching today. Have a great day.